Hi, my name is Saad Ibrahim. I am with Petro Management Group. It's a consulting company in Calgary. And I'll be the instructor for the class Water Flood and Enhanced Oil Recovery. In this class, we're going to start with Introduction to Enhanced Oil Recovery. We'll discuss the variety of different schemes around the world. We'll talk about the screening process for enhanced oil recovery schemes, so we can select quickly what scheme is more suitable for your specific reservoir. The next section will be on reservoir characterization. What sort of information we need to evaluate a water flood or any form of enhanced oil recovery, like for miscible flooding or chemical or thermal recovery. We'll talk about information we collect regarding rock and fluid properties. We'll talk about geology, reservoir heterogeneity, reservoir phases, and how this information can affect the performance of the field. So we'll talk about relative permeability curves, capillary pressure, rock wettability, and all the type of laboratory tests conducted on the fluid samples, such as the PVT analysis for oil to determine the bubble point pressure and the dew point for, say, gas condensate. There will be a variety of case studies to cover the subject and give you some practical insight to it. We'll get into the actual process of designing the water flood. So first we'll talk about reservoir drives and reserves. Some fields, they do have very high reservoir drives, like an active aquifer, that we don't need water flooding. The pressure is maintained naturally by, say, an aquifer. So how can we determine reservoir drives and the strengths of the aquifer, the drive indices? All of that will be discussed. And then we get into some of the technique used for reserves estimate, so we know what to expect in terms of primary production and in terms of secondary or tertiary when we apply these type of schemes. We move into the actual water flood design. So we'll talk about the one factor that affect the capital cost of the water flood, which is the injection requirement for the field. How much water we need to inject every day. That will affect the surface facility design and cost, the number of injectors we need to inject the required amount of water. We'll discuss the ways of water injection, how we inject water from pattern flooding to peripheral injection and gas injection. And then we move into the monitoring of the water flood. Once the water flood is in progress, how do we ensure the water flood will achieve the expected reserves and incremental oil? So we talk about all the techniques required for monitoring the water flood, from conducting pressure surveys, voidage replacement calculations, conformance plots such as the water-oil ratio versus cum production, and other techniques such as the HAL plots, and also checking the produced fluids, the water-oil ratio, all of these applications. Then once we've done with the monitoring of the water flood, then we're going to talk about the other section, other part of the class, which is the tertiary schemes. The second part of the class will be on enhanced oil recovery or tertiary schemes. So in this section, we'll talk about hydrocarbon miscible flooding. We'll talk about the different hydrocarbon miscible flooding, such as high pressure dry gas, or enhanced gas miscible displacement, or when we inject LPG slugs for miscibility purposes. So we'll talk about the ternary diagram on each one of those processes to describe it, and then we'll discuss the miscibility pressure, how we can estimate miscibility pressure, and the laboratory tests required for this estimate. We'll talk about the different options for miscible flooding, from injecting gas alternating fluid, for example. We talk also about CO2 miscible flooding and immiscible flooding. So we'll discuss first the physical property of CO2, from viscosity estimates, miscibility pressures, and also all the injection options, from CO2 injection and WAG process. After the miscible process, we'll talk about chemical flooding. We'll talk about the different chemical used for miscible for EOR projects, including polymer, surfactant, and alkali injection, and the incremental oil expected from chemical flooding. The last section will be on thermal recovery. So we'll talk about the different way to add heat to the reservoir from steam injection, which could be through continuous steam injection or half on puff process or the SAGD process. Also, we'll talk a little bit about air injection or combustion flooding. That is the content of the EOR part of the class. So if you have any questions, please let us know. Thank you.